Hello, great learners. This is Math Theatre TV. This is Mr. Innocent. On this channel, we groom our grade 12 learners preparing for Waec and their Jamb examination. So if you're seeing this channel for the very first time, give us a like, subscribe, and most importantly, turn the bell notification on so you get instant notification when we post one of these exciting lectures. Today, we'll be looking at simultaneous exponential equation, and we have one interesting question there. We are asked to solve these equations simultaneously. So quickly, without wasting time, let's see from the first question, from the first equation we have there, we have 5 to the power 4x. Now, okay, fine. If we go by indices now, this becomes what? 5 raised to the power 4x, all raised to what? 5 raised to the power 2. Indices law, one of the laws says that what? When we divide similar base, we pick one of the base and subtract the powers. So we return this to its initial expression. And here we have 2 in bracket. Also, we apply the same principle here. Here will be 4 raised to the power 5y divide 4 raised to the power 1. And that's how they got 4 raised to the power. We pick one of the 4s, then we subtract the power. So if we return that, that gives us 4 raised to the power 5y, all raised to what? All raised to 4 raised to the power 1. All right, then the right-hand side, we have 1 raised to what? Raised to 2. Okay, now from here, we can express this 4x now as what? As 5 raised to the power x, all raised to the power 4. In the denominator, that's 25 already. Then minus here, don't forget 2 cancel, here is 1, here is 2. Okay, then we can also express this 5y as what? As 4 raised to the power y, in bracket, raised to the power 5. All raised to what? All raised to 2. Then we have 1 raised to 2. Okay, because y times 5 will give us our 5y, so also s times 4 will give us our 4s. All right, so from here, what we do now is, okay, let what? Let p equals 5 raised to the power x, and let q equals 4 raised to the power y. Now, if that be the case now, so we're going to have, from this expression now, it becomes what? It becomes, we've said the 5x is p, so that gives us p raised to the power 4, p to the power 4, all raised to 25, minus, here becomes, we said let the q represent y, and let the q represent 4y, 4 raised to the power y, so we have q to the power what? 5, all raised to what? 2, equals what? 1 raised to 2. Equals 1 raised to 2. Okay. Now, what we'll quickly do from here now, we look for what? We look for the LCM of this, and the LCM what? Of 25 and 2 should give us 50. Now, 25 divided into 50, that's 2, and 2 times p to the power 4, that'll give us 2p to the power 4, minus 2 into 50, that's 25. 25 times this, that'll give us 25q to the power 5, and on the right-hand side, we have 1 raised to 2. Then from here, we'll cross multiply. This should multiply this should multiply this. And that will give us 2 multiplying what? 2p to the power 4 minus 25q to the power 5. On the right hand side, 50 will multiply y, and that gives us 50. So from here, if we open the bracket, we're going to have 2 times this, that will give us 4p to the power 4, and 2 times this will give us minus 50q to the power 5, all equals 50. So we can call this our equation 1. Then let's get to the second equation we have there now. So from this other one here, from 5 in bracket, 5 to the power 4x minus 1 plus 4 raised to the power 5y plus 1, all equals 29. From this other equation, from that other equation here, but we're through the first one. Now 5 in bracket, still applying the same indices law here, that will be 5 raised to the power 4x, all raised to what? All raised to 5 raised to the power 1. This is what gave birth to this. You divide by indices law, you pick one of the base, and you subtract the power. The power here is 1. So also, if we come to this other side, we have, here now we have addition sign. So this will be the same thing as what? 4 raised to the power 5y times 4 raised to the power 1. Applying indices law here. If we pick one of the base, since we are multiplying, we add the powers. So that gives us 29. Okay, so from here, the 5, we cancel out the 5 here. So we're left with what? 5 raised to the power what? 4x plus, here will give us let's leave it this way for us. 4 raised to the power 5y times 4 is equals to what? 29. Okay, now this can be expressed as what? As 5 raised to the power x, all raised to the power 4. Here becomes 4 raised to the power what? Y, all raised to the power 5 times 4 is equals to 29. Okay, now using same variable again like we did for the first equation, let p equals 5 raised to the power x and also q equals 4 raised to the power y. Now if we use that now to substitute here, we're going to have p to the power 4 plus q, which represents 4y now, 4 raised to the power y to the power 5, then times 4 equals 29. If we simplify further, that's p to the power 4 plus 4 times this will give us 4q to the power 5 is equals 29. So call this our equation what? 2. Now let's bring out both equations and put them in the right perspective. The first equation that we resolve, that gave us that's equation 1 here. That gives us 4p to the power 4 minus what? 50q to the power 5 equals 50. We'll call that equation 1. Then the second one we have now is p to the power 4 plus 4q to the power 5 equals 29. We said this is our equation 2. Now, resolving these two now, simultaneously now. Now, we can do this now. Okay, fine. The coefficient here is what? 1. The coefficient here is 4. So in order to use elimination method, one of the variables have to have the same coefficient. So what we'll do is this. We multiply equation 1 by the coefficient here, which is 1. And we multiply equation 2 by the coefficient here, which is 4. And by so doing, we end up having same coefficient for this variable. And we can easily eliminate what? Eliminate p. So if we do that now, 1 times this whole expression here will give us the same thing. So that will be 4 raised to the power 4 minus what? 50q to the power 5 equals 50. When we multiply all through by 1. Then here, if we multiply by 4, 4 times this, that will give us 4p to the power 4 plus 4 times this, that will give us 16q to the power 5. Then 4 times this, 4, 9, 36, that's 6 carry 3. 4 to 8 plus 3, that will give us 11. So if I call this equation 3 and call this equation 4, in order for me to eliminate my p now, I can say, okay, subtract equation 3 from equation 4 in order to eliminate p. Subtract equation 3 from 4, and that will give us 4p to the power 4 minus this, that will give us 0. So 16q5 minus what? Minus 50. Remember, we are subtracting. So 16 minus 50q will give us 16 plus this, and that will give us what? That will give us 66q to the power 5. Then here, remember what I just said now, we said we should subtract this from this. So that is 16 minus 50. So the two negative signs will now give us positive, and that's how we got 66. Then on this side, 116 minus this, that will give us 6 minus 0, that's 6, and 11 minus 5, that's 6. So yes, 66. Then to get the value of q, then I will say, okay, divide both sides. We divide both sides by 66. And when we do that, we're going to have q to the power 5 as 1. We're going to have q to the power 5. So to get the value of q now, q becomes the 5th root of 1. And the 5th root of 1 is actually what? 1. So that's the value of what? That's the value of q. Now for us to get the value of p, what do? It's okay, put q now equals 1 into any of the equation. So if we're using equation 2, substitute the value of q now as 1 into equation 2. So that gives us p to the power 4 plus 4, q to the power, q is 1 now. So that's 1 to the power 5 equals 29. Okay, so that gives us p to the power 4 plus 1 to the power 5 is 1 times 4, that's 4, equals 29. So when we move the 4 to the right hand side, p to the power 4 will become 29 minus 4, and that will give us p to the power 25. So let's come to the side of the board and see how we can complete the remaining part of what? Of this question. Now, so if we move the 4 to the right hand side now, p to the power 4 becomes what? 29 minus 4, and that will give us what? 25. So to get the value of p, what do? So p becomes what? The fourth root of what? The fourth root of 25. The fourth root of 25. But remember, we said but p is equals to what? 5 raised to the power x. And we'll call that q to be equals to q is equals to what? 4 raised to the power what? 4 raised to the power y. So what we're actually looking for is the value of x, not p and q. We'll introduce the p and q to be able to resolve this. So from here, what do? Now, we said p is equals to what? 5 raised to the power x from the beginning part of the question. So from here, we do this. P, from here, we've called it 4th root of 25. So if we replace p here with this, so that gives us what? The 4th root of 25 as the value of p now is equals to what? Is equals to the 5 raised to the power what? X. And when we do this now, 25, the 4th root of 25 can also be expressed as what? As 25 raised to the power what? 1 over 4. And that's equals to 5 raised to the power x. Then the 25 is the same thing as what? 5 raised to the power 2. 5 raised to the power 2 raised to the power 1 over 4 is equals to 5 raised to the power what? X. Okay, from here, 2 cancel out the 4 here, that's 2. So we end up having 5 raised to the power 1 over 2 is equals to 5 raised to the power what? X. So when both of them cancel out, the value of our x now is equals to what? Half. Now, why? If we go back to what? P, remember also we said, but q is equals to what? It's equals to 4 raised to the power what? Y. We got the value of what? We got the value of q as 1. So if we replace here now, since q is equals to 1, we replace the q 1. So we have 4 raised to the power what? Y. Now, let's see how we can resolve this here. Remember that what? That 1 can also be expressed as what? 4 raised to the power what? 0. And that's equals to 4 raised to the power what? 4 raised to the power y. So the 4 and the 4 can cancel out, giving the value of y to be 0 and the value of x to be half. And that becomes the solution to that simultaneous equation under this very topic. So that will be the size of our lecture today. If you've gotten any value from today's lecture, do well to hit the like button, subscribe, and most importantly, turn the bell notification on so you get instant notification as we begin to review some of these questions you are likely to see in your Waec and your Jamb examination. So until I see you in our next lecture, don't forget this is Math Theater TV. This is Mr. Innocent, and your success is my delight. Peace.